Well, hello everyone, but I just want to touch bases on a few things. Um, a lot of times working on vintage radio, we come into problems where we have to make specific parts that you just can't buy. And it's like these little coupler shafts here. I know it's kind of hard to see. I got to get a macro lens for this camera so I can get some tighter up close. But you see, this is a threaded shaft with a groove on it, and this is going to be for a control extension. And this groove will actually have a C-clip on it that holds it into the front panel. And this is another one for a different control. And these are just some spacers for a variable capacitor that's going into a piece of equipment that I'm working on, and there's being these two holes here. And the things that I don't never show is actually making this type of stuff, and the real reason is the crude method I have to use to make such things. So for designing the pine board project in a metal case, there'll be a lot of different things that have to be fabricated and made. For that, we'll need nuts to go on the front panel where shafts go through, and what it is, just it's a bearing nut that will go into the front panel with a nut behind it so that the shaft don't wobble around in the front panel. So we'll have to make those couplers. Some of the controls, like this is the front panel here, and then the control is going to sit way back here. Then we got to make couplers to tie the shaft together, and then we're probably going to use fiberglass shafts that will won't radiate RF through it and stuff. So a lot of stuff that has to be made. But like I said, the way that I've been making this stuff is very crude, mostly with a drill mill machine, and it has the wrong arbor in it, and files and sandpaper and so forth, to make these little controls and parts that we need. So sitting here, we are in the garage. So sitting here is my old drill milling machine. It's a Speedway series. It's old. It's been around a long time. I bought this thing in the 90s, back when I was racing go-karts, and I started building my own engines, and I needed a way to mill and drill different parts, and I picked this up at one of those tool sales for like $425 back in the 90s, and it has served me pretty well as far as that. It is not a great milling machine, and the reason is that I have a Jacobs chuck on it, as you can see, and on top of the Jacobs chuck there's a disc here, and there's 3 screws in it. So what you do, you put your part in it, you put a dial indicator on it, and you turn it around and you adjust those screws to try to get the run out. Well, a Jacob truck is not made for milling. That's all it is to it. But it does work for what I've been doing. So as you can see, I got a cutting tool mounted in the vise, and I'm cutting a groove into this piece of hex stock, and it's threaded on the inside, and this is I think 3/16 headstock, 3 millimeters. And what I'll do is that one end will have the hex on it. You turn this down and cut it off, and you take this piece and insert it into a hole and mushroom the backside over, and it makes a blind nut. And you get a lot of radios, the screws will no longer fit in. You drill out the hole, I make these, insert them, press them in, mushroom the back, and now I have a new threaded insert that'll hold the original size screw. And like I said, this is a kind of a crude way to do it, you know, and constantly have to keep your files and different things around. You know, this is a bolt that I needed on a mower, and you can see I've milled a C-clip groove into it, and that holds the bolt in place so that when you take the nut off, the bolt doesn't drop off. Again, very crude, but it's the way that, you know, we sometimes have to do stuff like that. Now, it took me the longest time to figure out that this Jacob's truck comes out of this machine. So under the head, under this first pulley here, you see when it goes up and down, you can see that nut going in and out. Well, that happens to be a drawbar. So when you loosen up the drawbar, give it a little tappy tap tap. We can unscrew the drawbar, and you can see this Jacob's chuck is mounted on a MT2 arbor. That's moist taper 2. Well, I got online and started looking. I can actually buy a threaded moist taper 2 arbor with a collet on it that will hold end mills and different things. So I'm gonna order up one of those and try that on that, and I'm gonna do a little cleaning up and restoration to this old machine and get it so we can do some fairly accurate milling with it. And it took me the longest time to even realize that this came out of the machine. I think I used this thing for 15 years or so before I even noticed that. And what happened one day, this little plastic cover that was over just popped off, and I saw that nut in there spinning for the drawbar. And that's when I realized that this machine had a replaceable arbor. So, and you know, you can get all types of milling bits with moist taper 2 on it. They just got to be threaded for a drawbar. You cannot do any milling on anything like this unless you have a threaded drawbar, because any side load on this will cause this MT2 to come loose out of the taper. So thanks to my supporters on Patreon, I went and bought this little piece of equipment from Harbor Freight. And what we have here is a 7x10 mini lathe. So let me go ahead and get this thing out of the box. It weighs about 100 pounds, and we'll get it out and take a look at it. Okay, so here we go. It's the Harbor Freight Central Machinery 7x10 Bacid mini lathe. And as you can see, it's not very big. I mean, there's a chuck. There's my hand over the chuck. I think it's a 3-inch chuck. And it's coated with this rust prevention grease that I've got to remove, and then oil everything and get everything cleaned up, and then go through and check all the nuts and bolts, make sure everything's tight. Just several, you know, things that need to be done to it. One thing is that it's sitting on, I took it off the little pallet that it was on. I put the rubber feet on it, and you know, it's not very solid. I will be building a bench top height bench for this out of metal that can be moved around, so to have at least have 2 wheels underneath the bottom of it, so you can pick up one end, move it where you need to, and then lock it down. Do not have the guards on yet. It's got a plastic guard that goes here, and then there's another chip guard that goes over here. It has the rear metal chip guard and a chip tray underneath of it. Now, what does that mean, 7 by 10? That means that it will swing something 7 inches in diameter, 10 inches long between centers. And that is always very misleading. Just because it say that. I mean, you would never want to grab a piece of steel that's 7 inches by 10 inches long and put in this thing. I mean, that weighs almost as much as this machine does. And it could probably hurt you. But, you know, there's wiggle room here. So when you put the tailstock in, being if it's a live center, you adding a couple more inches, so that gets you down to 6 inches. And then when you put the Jacobs chuck in and a drill bit in it, then you know you're taking the distance between centers even down further. Now you might be saying, well, buddy, they got a 7 by 12 online for $500. You know, what didn't you buy it? Well, several reasons. I'm going to be working on small parts, not large parts. So the 7 by 10 will do exactly what I need for radio work and some small engine stuff. Now, if you went online and you ordered that 7 by 12, it's only going to give you 2 more inches. But, you know, you got to pay that shipping to get it here, and you got to coordinate with the shipping company to make sure you're here to get it unloaded, and blah blah blah. Well, I'm a type of person that I like to be able to walk into a brick and mortar place and get what I want instead of ordering stuff offline. That's just the way I am. It's the way I've always been. That's why I miss being able to walk into at least Radio Shack or places like that that sells electronic components. I will pay more. I can go to Thompson TV over in Washington, North Carolina. That's about 22 miles away, and I can walk in there and I can buy some electronic components. I pay more for them, but I like walking into a place and touching and feeling what I'm buying, and that's one of the reasons why I just went into Harbor Freight. In fact, I had to go to the Washington store to get this, and it was about $600. Now there's a lot of lathes on the market, and they are all based off the Asian market design. It just depends on, sometimes you buy some of them, they go to a third party and they get upgraded, and the quality is built into it there, and then they're shipped out, and the lathe might double in price. So, you know, if you get a Bolden or a Grizzly or a Precision Matthews, and you know, they're all Asian made lathes. The Central Machinery is built directly in Asia and then shipped over here to Harbor Freight. So there's a lot of stuff that needs to be gone through to upgrade this lathe to make it a little bit better. The way that the cross slide is mounted to the way needs to be upgraded. There's a few problems in that I've seen on looking at different reviews, and that's another reason why I'm not going to do a review on the lathe, because you can go on YouTube and there's hundreds of reviews on this lathe already, and those guys, or most of them, a lot of them are full machinist and no machinery in and out. You know, I'm a entry-level machinist. I was an FMO operator. I run tool and die when I worked for Firestone over there in maintenance. I did tool and die there, but I don't call myself a professional when it comes to machining. But there are certain things I do know and know how to do. So let's look at what comes with the lathe. You get the manual, quick start guide, a couple of tags, there's a live center, and I'm standing on the wrong side of the camera, so I can't really see the display. But you know, there's a live center. and it goes into the tailstock. And it just wedges. This is moist taper too. And okay, so when you want to retract that, when you screw the tailstock all the way back, it'll automatically retract the live center. You have a lock, locks the tailstock slide in place. One thing I don't like about the way this lathe is designed, it uses a nut here that you have to loosen with a wrench to move your tailstock back and forth. And the problem that causes is that you can already see the cross slide is sitting here, so when your tailstock goes forward, it can actually, this nut can actually be behind it. It makes it a little difficult, you know. You got to move your cross slide out of the way, and still, depending on how far you get it up, it can get in the way. Now there is upgrades for this too. You can change this out. I think it's the little machine shop online. They sell all kind of parts for these. You can change this out to a cam lock or a lever lock, and it makes it a little bit easier to run. But you got this bag here that's full of parts, and we'll look at it and see what we have. If we look at our bag, we got a little oil bottle with a small wrench, pack of Allen wrenches. There's a larger wrench that fits the tailstock nut. And then there's all of these. And what these are called change gears. And that's how you speed up and slow up the cross slide when you're threading. So if you're going to thread something, you look at the chart and you get your threads per inch or whatever. And luckily this is in imperial, it's not in metric. And you change out these gears to get your speeds correctly to thread with. On the back is this cover here, and you can see there's different charts here, and that gives you your speed ratios on setting. If you take this cover off, and you can change out these gears to get your speeds correctly. Now these gears are plastic, and with any plastic gears, you know, you got plastic gears in everything these days, and they seem to hold up well. But one thing that I have seen when people had these is that these gears would crack across the keyway here. Now this gear is completely different than the ones I've been seeing on the internet. These have ribs in them. They're black plastic. I don't know exactly what they're made out of. It doesn't really tell me. Each gear is numbered, but maybe this is a better gear than what they used to use, because the gears used to be white and now these are black plastic, so maybe they'll hold up better. Now you can go online also. I think Little Machine Shop carries them, eBay. You can buy these gears that are metal, and I've seen them anywhere from $100 to $150. So you know, it depends on how hard you push this thing. If you start trying to put it through some deep cuts and stuff, you can damage these gears. Probably with this motor being as small as it is, I think it's a I said it was a 3/4 horsepower, but I think it's somewhere between 500 or 600 watts on the motor. I have to go in the manual and see. You'll probably stall out the motor before you get it into too big of a cut. But remember, every time you're doing that, you're putting wear and tear on everything. It's a small mini lathe, guys. It's not made to do big jobs with. It's made to do small jobs. Okay, so we have another bag here. And we'll take a look at what's in that. There's another set of jaws, and I believe these are the outside jaws. And our wrench for our chuck. And you see it's got a square head on it, and it's also spring loaded, so you can't leave this in the chuck when you turn it on. It'll actually push itself back out, and it's a good safety feature, you know. And that was pretty much everything that comes with the lathe. There is 2 boxes over here that has the guards on it. This is the main chuck guard. Goes up high as the chuck. I don't really care for guards. I know you should use them, but they get in the way. You can't see what's going on. You know, when you're using a piece of equipment, make sure you wearing an apron, keep hot chips off of you. Eye protection. I always wear impact glasses, and I have side shields that clip on. But what doesn't come with the lathe? Well, this is an item here I bought. This is a 1/2 inch MT2 drill chuck, and if you're going to bore holes or drill holes, you'll need a chuck to do that with. We have the chuck key, and we have the Jacob's chuck. It'll hold up to a 1/2 inch bitch with a MT2 taper. Now this doesn't have threads for a drawbar. So we should be able to remove this and insert this right in place, and there you go. Again, like I said, you know, whenever you're adding more stuff like this, you can see how much further this sticks out. So now we're out to about 6 inches just for this. But if you're going to bore holes, that's what you'll need. And unlock it, retract, and pull right out. Stick this back in the box because we don't need it right now. Then there's tooling. This is a 5-piece set MS high-speed steel mini tool bits. Cut that open. We got a piece of 1/4 inch round stock. There's a 1/4 inch by 2.5 inch piece of high-speed steel. There's a 3/16 high-speed steel. That's a 1/8 piece of high-speed steel. These make good grooving bits. And then there's a 1/16 by 1/2 inch by 4.5, and this is a parting blade. This goes in to part off your work. Now every one of these will have to be ground. You just can't use them like it is. You got to ground your angles and your rake and everything into those to do your grinding, your milling with. So with that comes said, it's time that I got to go buy another bench grinder that has some adjustable plates on it, because you want to get this at about 10 degrees and cut your angle and your rake and stuff into it and make, you know, what's called single point cutting tools. And high-speed steel is probably one of the best cutting tools that you would ever use on a small lathe like this. You can get a lot of carbide. Carbide is more expensive. You have to turn it at a faster RPM than you do high-speed steel. So most of the high-speed steel you buy blanks and you grind your own tools. Lots of videos online doing that. I know Quinn over at Blondie Hacks. She's a machinist, and she's done a lot of tutorials on milling and drilling and with lathes and milling machines, and she shows recently put up a video on how to grind your own high-speed steel bits. Now this is a 5-piece tool set, and these are 5/16 inch shank. It fits this tool post that's on the machine. This is just a regular tool post. It's not adjustable or indexable. In other words, you put it in, a 5/16 works good. It holds. People tried 1/4 inch, people tried 1/2 inch. 1/4 inch is too low on your center line. You want your cutting point in the very center of your work. 1/4 inch, like I say, is too low. You can shim it up. 1/2 inch is too tall and puts your center line above it, so you would have to come in and grind down the bottom of your tooling to get the your tool height correct. And you see we have a parting blade, a couple of right angles, left angle for boring inside or outside, single point thread. And what these are I think high speed. I believe this is high speed tooling. Drop forged steel tool with tungsten carbide tips. So it has tungsten carbide tips that are brazed into the tooling. Here's another set. This is a 6-piece. Same thing, got tungsten carbide tips. And if you're first learning how to use up a lathe, you'll go through these things quick. And Harbor Freight, they're pretty cheap. They're not that expensive. But you can see these are for inside boring. You drill a hole and you need to bore it out. This is for boring that, different rakes on it, different angles. Same thing. Each one is angled just a little bit different. Well, I did a little bit of tightening and checking stuff. I got a piece of bronze in the chuck. I'm going to dial in about 5 thousandths. And we're going to turn it on. Since we're using high-speed steel, we're going to run it at about 500 to 600 RPM. Go with about a 10,000th cut this time. And I got to say, the surface finish is pretty darn good. Nice and shiny, no chatter, no tooth marks, looks real good. So I'll crank back over. I pulled the blade out, I'll turn it back on. It's 15 thou at a cut. And I'm gonna tell you, that looks real nice. Alright, so that turned out real good. One thing I need to do is make a set of soft jaws for this. And what I want to do is turn it around like this. And then you can mill the other side down the same as that. But the jaws will bite into your material and leave tool marks on it. So by making a set of copper soft jaws that'll go around here and lock in place and you slide them on, you don't have to worry about messing your tool, putting tool marks in your piece. And there you go. There's a bronze rod cut down to the side that I need. And what we'll do, will be boring this, threading, and making nuts to go on the front of the control panel on the radio. That's a way to hold the control shaft without wearing out. And it did a fairly decent job. Okay, so now what I got to do is take all this apart and clean it real good. I don't like I didn't want to clean it while I was doing those test cuts. I know it gets chips everywhere and chips all in the ways and stuff from that grease, but I didn't want this thing to rust overnight out here in the garage. It's not environmentally controlled out here in the garage, so I just want to leave some of the grease on it. But now anyway, I got to address known problems with this anyway, so I need to pull everything out, give it a good cleaning, and put it back together, make sure all the bolts are tight. It's doing a fairly good job. Then I can spray it down with some WD-40, and every time you finish using it, you wipe it down, spray it with WD-40 to keep it from rusting. That keeps, you know, WD-40 is water displacement, so it keeps the moisture off of it. A few more things I gotta have. I didn't buy no center drills to go with the chuck to bore in it. I also want to change out this tool post to a quick change tool post, because right now, you know, there's not a lot of travel. It's only like 2 inches or so back from the chuck, and putting some of the tools in here, you know, I've seen people put multiple tools in here, but those are so long they would have to be cut off because they would stick out so far. You know, you could run one out this way and then one out this way. They stick out too far like that. So I want to change this over to a quick change tool post. And what that does, it gives you the opportunity when you change tools, you slide it on, lock it down, and you can adjust the center. Whenever you take this tool off and put it back on, it's automatically adjusted. You don't have to worry about it. With the parting blade that I got, there's no way to hold that parting blade in this tool holder because it's too high, and you got to have everything center of your work, especially if you're parting something off, or even milling, you know, turning something. You want all your work center. So an adjustable tool post would be the next thing. That's about another $100. More high-speed steel blanks to go ahead and cut my own tools. Like I say, I'm gonna have to buy a grinder just for that, with those white oxide wheels, that little gray stuff. So yeah, I'll have to get that. Later on, if I decide that this just isn't big enough, you can order a new bed and lead screw for like $190 up to 16-inch, and everything else is the same. It's just that the bed is longer. But you got to remember, you know, the more you try to put on it, the more load you put on this little machine, and that is going to cause it to wear out quicker, and you don't want to do that. Anyway guys, that's it for now. Need more toys for the shop to help further radio advancement, you know, and making the things happen. So hope you enjoyed that. You'll be seeing some more. Wondering right now if I should start another channel and put all my garage stuff on that channel, or just keep it on this channel. Thinking either way, you know, the idea of starting another channel and having produced content for that, you know, and then for Patreon, and then for YouTube on this channel. It's a lot of work. But we'll see how it goes. Anyway, I'd like to hear your comments down below, and we'll see you in the next video. Bye now.